Now let's look at the common mistakes people make with binary tree code and how to avoid them. Let's look at the most common tree bug. The left side is the buggy version of preorder. The right side is the fixed version. The buggy version starts by printing X arrow data. It reads from X right away. It never checks if X is null first. Then it calls itself on X arrow left. It also calls itself on X arrow right. Sooner or later one of those children is null, and we still try to read from it. The fix is one line. The first line says if X is equal to null, return. This is the base case. It stops the recursion at an empty spot before we read anything. The tricky part is this. The crash only happens once we reach a leaf. A leaf has null children. Every node above it has at least one real child, so the crash looks like it comes from deep in the tree. Let's test yourself. We call preorder bad on node 77. It is a leaf, so its left child is null. What happens? Think for a moment before the answer. It prints 77. Then it calls preorder bad on X arrow left, but X arrow left is null. The function reads X arrow data right away, so it reads from null. That is a segmentation fault. The base case is not optional. Every recursive tree function needs the null check as its very first line. Preorder, inorder, and postorder differ by just one line's position. If you move that line by accident, you get the wrong order, not a compile error. This function is called oops. It was meant to be in order. Look at the print line. It prints X arrow data before the left call. That makes this preorder not in order. The visit happened too early. The left call and the right call come after the print. For in order, the print belongs between them, not before. The symptom is quiet. The output is a valid traversal, just the wrong one. Nothing crashes, so a quick test can miss it. The fix is to compare your code against the pseudocode, line by line. Check where the visit sits, not just that every value printed. This is a level order bug. We start by putting root into the queue. So far so good. The queue now holds one node. The loop runs while count is greater than 0, that is, while the queue still has nodes in it. Inside the loop, we take the front node out of the queue and call it X. Then we print X arrow data. That prints the root. And here is the bug. We forgot to add the children to the queue. We never enqueue X arrow left or X arrow right. The symptom is clear once you see it. The program prints only the root. Then the queue is empty, count goes to 0, and the loop stops. The rest of the tree is skipped with no crash and no warning. The fix is simple. Every time you take a node out, you must add its real children back in.